Another big vulnerability in web applications that involves databases and that is called Sql Injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the first time, you might find this a little bit hard. However, through practice, this will become easier and easier. Here we can see an example of how a real-world SQL query could look like. Here, books are our table from the database, ID is our condition, and this star sign indicates that we want to extract everything. Usually in programming world, star sign means everything. Great. Now that we know behind the scenes of how an SQL injection works, let's try to perform one on our DVWA page. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to low and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now, let's just focus on this SQL injection tab. So, what do we have right here? We have something called user ID. And usually, we would input something like a number right here. So, let's give it a try. If we, for example, input number 1, and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin, and that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2, his name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal, let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is, instead of these two, and instead of it filtering the apostrophe, it just writes it between these two single quotes. And then we get three single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that has one single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection, because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these two. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we'll just get the information about user under the ID 2. And that's because our statement is correct. So we select the user ID 2 and we say do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. That could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as, for example, this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1, and add dash dash, then space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment, and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1 will just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we'll get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error, unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2, And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. The first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user, and type it right here, and we get the first name, which will store the database name, which is dbwa, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. These select statements you can also type in capital letters. It doesn't really matter, you can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for schema underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore schema dot schemata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DBWA database, we got Metasploit database, MySQL database, OWASP 10. And since we're doing this all inside of the DBWA application on our Metasploitable, we would most likely be interested in this DBWA result. So let's try to extract even more from it. We can use the following command, which is id2 and then union select table underscore name, comma 2 from information underscore schema dot tables. You might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema dot tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is dbwa. So we can just type equal open single quote dbwa close single quote and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is 2 and then single quote and then union. Click on submit. And here is the output. So with this command, we sent a query where we requested names of all the tables inside the DBWA database. We got 2 results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with 2 and then apostrophe, union, select, and now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type, from information underscore schema dot columns. Remember, in the last command we used dot tables. Now we are using dot columns because we are furthermore diving into our database, and we need a condition at the end. So where table underscore schema is going to be equal to dvwa, and table underscore name equals users. So remember, we got two results right here, and we want to go with the users one first, because that looks more interesting to us than this guestbook table. Okay, so let's copy this command, and now I'm going to copy the entire command. So select, copy and paste right here, and click on submit. And again, we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have two fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like if I go back and add a few more spaces. Let's type 2 and then apostrophe, union, select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with two dots. So comma, and then first underscore name, which is going to be our second field, comma, let's use again two dots to separate that also from the last name. And these are the three fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called dvwa, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. Add the comment at the end. And let's copy all of this. And submit. Well, here it is. Here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name. And in the surname field, we get the username and the password. So we successfully performed SQL injection, and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened, and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords, so let's go with this one for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC 123, because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one, for example, go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we're going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video, we're ready to continue discovering even more bugs on our DVWA application. See you there. Welcome back. Let's talk about another big vulnerability in web applications that involves databases, and that is called SQL injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the first time, you might find this a little bit hard. However, through practice, this will become easier and easier. Here we can see an example of how a real-world SQL query could look like. Here, books are our table from the database, ID is our condition, and this star sign indicates that we want to extract everything. Usually in programming world, star sign means everything. Great. Now that we know behind the scenes of how an SQL injection works, let's try to perform one on our DVWA page. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to low and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now, let's just focus on this SQL injection tab. So, what do we have right here? We have something called user ID. And usually, we would input something like a number right here. So, let's give it a try. If we, for example, input number 1, and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin, and that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2, his name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal, let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is instead of these two, and instead of it filtering the apostrophe, it just writes it between these two single quotes. And then we get three single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that has one single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection, because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these two. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we'll just get the information about user under the ID 2. And that is because our statement is correct. So we select the user ID 2 and we say do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. That could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as for example this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1 and add dash dash and space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1 will just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we'll get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error. Unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2. And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. The first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user and type it right here, and we get the first name, which will store the database name, which is dbwa, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. These select statements you can also type in capital letters. It doesn't really matter, you can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for schema underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore schema dot schemata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DBWA database, we got Metasploit database, MySQL database, OWASP 10. And since we're doing this all inside of the DBWA application on our Metasploitable, we would most likely be interested in this DBWA result. So let's try to extract even more from it. We can use the following command, which is id2 and then union select table underscore name, comma 2 from information underscore schema dot tables. You might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema.tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is dvwa. So we can just type equal, open single quote, dvwa, close single quote, and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is to and then single quote and then union. Click on submit. And here is the output. So with this command we sent a query where we requested names of all the tables inside the dvwa database. We got two results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with to and then apostrophe, union, select, and now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type, from information underscore schema dot columns. Remember, in the last command we used dot tables, now we are using dot columns because we are furthermore diving into our database, and we need a condition at the end, so where table underscore schema is going to be equal to dvwa and table underscore name equals users. So remember, we got two results right here, and we want to go with the users one first because that looks more interesting to us than this guestbook table. Okay, so let's copy this command, and now I'm going to copy the entire command. So select, copy and paste right here, and click on submit. And again we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have two fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like if I go back and add a few more spaces. Let's type to and then apostrophe, union, select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with two dots. So comma and then first underscore name, which is going to be our second field, comma, let's use again two dots to separate that also from the last name. And these are the three fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called dvwa, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. Add the comment at the end. And let's copy all of this. And submit. Well, here it is. here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name, and in the surname field, we get the username and the password. So we successfully performed SQL injection and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened, and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords, so let's go with this one for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC123 because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one for example, go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we're going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video we're ready to continue discovering even more bugs on our DBWA application. See you there. Welcome back. In this video I want to talk about a vulnerability called Csrf, or also known as cross-site request forgery. Now, this is something that you might remember from the scanning section of the course, where we used Nmap to discover vulnerabilities, and on one of our targets we got response that possible Csrf vulnerability was there. Well, the time has come to finally see what is this vulnerability. Many people think that this is something similar or the same as XSS or cross-site scripting, but that is not the case. In cross-site request forgery, the attacker makes the identified user execute something that they didn't want to execute. Csrf attack can be used to exploit any web function that searches for one request inside of the identified session in case the security applied isn't efficient enough. Some of the things that you can do with cross-site request forgery would be something like changing details about a specific user, like email addresses, date when they were born, and so on and so on. You can also perform fake banking transactions, adding items to buy on a certain page, but this is not something that we can accomplish easily. For this attack, we need a victim that has active identified session inside of the website, and they will also have to visit our URL link that we craft in order for this to work. Now, let's take a look at simple example of how to do this on our DBWA page. So start your Metasploitable, visit the page as usual, we want to go to the DVWA and we can log in right here. But remember that we did the SQL injection? We no longer have to log in as admin user. We can log in as any other user from the data that we extracted with our SQL injection. So if you remember, we had a user called Gordon who had the username of Gordon B, and his password was ABC123. If you remember that we got his MD5 hash, then we pasted it inside of the Google, and we got that his hash was equivalent to a string of ABC123. So we can log in as Gordon. And we can see down here, you have logged in as Gordon B. Now let's set the security to low. And let's navigate to Csrf right here. So we can see vulnerability, cross-site request forgery, and the application requires us to change our admin password. So we got the new password and confirm new password. What we can do is we can, for example, type password 123 and confirm password to be password 123. If I click on change, it says password changed, and let's see whether it indeed got changed. So if I log in as admin and then password, remember that before it was just password, now it is password 123. If I log in, well, now it will work. We successfully changed the password. But how can we use this to exploit it? Well, if I go right click and go on view page source, there will be a vulnerable part of code inside of this page. And that part of code will be the form where we submit the new password. If we scroll all the way down, here is the part of the code that is vulnerable. We got the form where we can submit the new password, where we can also reconfirm the new password, and you will notice that this is under the vulnerable code area. So what we can do with Csrf is we can copy this vulnerable form where we submit the username and password, and we're going to create our small HTML page that we're going to host on our Apache 2 web server. And you're going to see in just a second why we do that. So I'll open a terminal and I will navigate to the directory of our web server, and if you remember, that is /var/www/html. Now, since we can't write files right here as a regular user, let us enter the root account. If I type ls, we got our tester.py, we can remove it, we no longer need it here, and once you got this directory clear and empty, let us nano csrf.html file. Let's call it like that. Now feel free to call it anything that you want, just make sure that you have this HTML extension onto this file. Now that we opened it, we can paste the code that we copied from the page, and you will notice it is the form where we change our password. Now, there are a few things that we want to change right here. For example, this action, we want to change to the page link where we change our password on our DVWA, and that page link is this link right here. Let's copy it, let's paste it right here. And what this action simply refers to is once we change the password, it will redirect us to whatever page is inside of this action field. So it will just redirect us back to this page right here. Let's copy this and paste it. Now that we got the page right here, there are two more things that we need to add in order for this attack to work, and that is inside of these input fields. So we got the name of the field, which is password new. I believe it is this field right here, and the second field is confirm new password, which is this field right here, password confirm. We want to automatically add value to those fields, and in this case, that value will be a new password. So what we can do is we can type space right after the password name, and we can type value equals, open double quotes, and in between the double quotes, we can type the new password. Let's say the new password is hacked. We must do that for the second field as well. So value equals, open double quotes, and then hacked. Now, you will notice once we visit this page that in that case, the fields will already be completed. They will have this hacked value inside of both of these fields. Let's give it a try. If I save this, Ctrl O, and I start my Apache 2 web server by typing service Apache 2 start. all we need to do right now is visit our localhost and the csrf.html file, which is the only file inside of our Apache 2 web server directory. So we got this right here. And this is the link that we would want to send to our victim. Now I know it doesn't nearly look as good as this page right here, but let's just give it a try to see if it works. If we did everything correctly, once we click on this change button on our localhost Csrf file, we will successfully change the password of the admin account on this DVWA page. So we send this to the target clicks on change, and we get redirected to our Metasploitable DVWA Csrf page, and it says password changed. Let's see whether it indeed got changed. Remember, we typed the value of hacked, and now if I go right here and type admin and hacked, well, it worked. We logged in with new password that someone typed in while visiting our page on our local host. But if you noticed on this page, we only copy the form, and if we were to host just the form code on our Apache 2 server, like we're doing right now, it would look suspicious, because if we take a look at this page and this page, they don't look nearly the same. So how can we make it look the same? Well, first thing that we must do is we must go right here, right click, view page source, and we must copy the entire HTML code and not just the form. So what you can do is you can select the page, type Ctrl-A, it will select all the code inside of this file, and we can copy it. Then we can go to our Apache web directory and we can remove the Csrf file and we can nano new one. Here we will paste the entire code. And remember that we must do the same thing that we did inside of our form. So find the form code, and here we want to put the link to our page, which is this link once again. Copy it, paste it right here. We also want to add the value to our password fields. We can change right now the password back to password, just so we put it back as it was. And now that we did this, we can save this, and if I go and visit a page once again, or I just reload this page, well, it looks a little bit better, but it is still not the same page. We're missing some decoration that this page has. And if you have some experience in web development, you will know that we're missing the CSS file. So what we can do to add the CSS file is we can go to this page source of our page that we got open, and we can navigate to the CSS file. So just search for any file type that ends with .css. And if I go up here, here is one of them, and it is called main.css. And by looking at this page, it seems that this is the only CSS file that this page has. So let's click on that, and here is the CSS code that we also must save in the same directory as our HTML file. So let's select everything, copy this, and let's go back to our web directory. Right here we're going to nano main.css, and let's just paste all of this code. Now that we have the CSS code right here, we can save this, but it will still not work if we don't change the file location inside of our code. Because if you take a look at right here, where we add the CSS file, it is still the location on our Metasploitable machine. And since we have it in the same directory as our HTML file on our Apache 2 web server, what we can do is we can just remove the entire path and leave just the name of the file, because they're both located in the same directory, so we can just leave it like this. Then we can save this. And now if we refresh our local host page, well, now it looks the same. Just this page isn't zoomed in, so what we can do is we can zoom this in and they look exactly the same. So the password is, remember right now, just the password, and if we click on change, it will redirect us to the real page and it will say the password has changed. Let's give it a try once again and see whether it indeed got changed. So I will just go to my DVWA page, log out, and type admin and then password. And we did it again. Just this time we made our page look exactly the same, as we can see right here. Great. This is the Csrf attack, or cross-site request forgery attack. As you can see, it requires to open our link, otherwise this will not work. But if you manage to trick them by making the page look identical, then this attack will work and you will successfully change their password. Now this can be performed on other stuff and not just the password fields. As we remembered, you can use this to change emails, to change dates, and many other things as well. Now that we covered this, in the next video we're going to cover brute force attack. And we're going to see how we can perform the brute force attack in 2 different ways. So thank you for watching, and I will see you in the next lecture. Bye. Welcome back. And in this lecture, I want to talk about the subject on brute forcing different login pages. So we talked about many different attacks that were based on some type of a vulnerability, either a code injection or Csrf attack or command injection. All of those were bugs that we covered. But we haven't covered how to brute force a login page. And for this entire section, we have been logging into this username and password field whenever we want to access the DVWA page. Let's say that we don't have the credentials for this page. We know, of course, that they are admin and password, but let's also see how we can try to brute force them, how we can try to guess the credentials. Of course, for this, we're going to need to have a little bit of luck, because this will require that inside of the password list that we're going to use, we have their password there. So this will only work if their password is pretty weak, which in our case it is, since the password is just password. For this, we're going to use a tool called Hydra. And Hydra is already pre-installed in Kali Linux, so you can just type Hydra inside of your terminal, and this will give you the help menu of the tool. However, I advise you not to look at this help menu, because it will be in no way helpful for these types of the attacks. As we can see right here, it gets the example of usage, but once attacking the actual web pages, this becomes harder and harder to use. The syntax becomes harder and harder. So I advise you to actually pay attention once I'm writing syntax, so you can see how exactly am I doing it, because for every web page that has a login page with username and password, this syntax will be different. So let's start crafting our command. We're going to start with Hydra, and then after it we specify the IP address of our target, which in my case is 192.168.1.9, as we can see right here. Then you got a few options that you need to specify right here, which are based on how are you sending the username and password to the target. So in this case, if I type test right here and test as password, I click on login, this is being sent as a post form. So we are applying these usernames and passwords to the form, and we are sending this to the target with post request. You can always check that right here inside of your burp suite. So you can go down here and we can see that this is a post request where we send the test username and test password. Okay, so how we can specify that inside of Hydra? Well, we can specify http-form-post. After this, you need to open the double quotes, and in between the double quotes, the first argument that you must specify for the page that you're brute forcing is the path to that page, which requires username and password. And in our case, that path is /dvwa/login.php. So that is the first argument specified in between the double quotes, and arguments that you specify between these double quotes are separated with 2 dots. So once we type the path, we type 2 dots for the second argument, and the second argument is the username. So for this, we must go to the page that we are brute forcing, we must right click and go to view page source, and we must find the name for the username field inside of the code. Usually the username and password fields will be inside of some type of a form, as we can see right here, form action login.php method post, and if I go to the label for the username, we can see that the name for the username field is simply just username. Okay, so we must copy the name of this field and we must go right here and type it in. So paste it right after, and this username field will be equal to upper arrow and capital user, and then once again upper arrow. Now you might be wondering what is happening here. Well, after we specify the name of the field on our page, we equal that to this syntax right here, and this is just Hydra syntax. You use this upper arrow right here, and you type user in between that, and you close it with upper arrow. What this is telling to the program to do is it will exchange any username that we have in a list between these two upper arrows. So essentially any type of username from the list that we're going to use will be stored right here. But this is not the only field that we have, we also must specify the same thing for the password field. Now, to separate the username field from the password field, we use this sign right here. So specify this sign, and then after it, we can specify the password field name, just like we did right here. So let's go and find the label for the password, here it is, and the name for the password field is simply just password. And this is something that can change depending on which page you are brute forcing. So let's go right here and type password, which is the name of our field, and this will be equal to upper arrow and then pass, and then once again upper arrow. And this is also the same as with the username, so just any passwords that we use from our list will get stored right here instead of this capital pass. And the last thing that we must set for this second argument of our command is the button that we're using. So every time you actually try to log in, you click on this login button. And this is something that we also want to simulate inside of our Hydra command. To do that, we go view page source, we find the button, which is usually right after the username and password field, and in our case here it is. We take a look at the type of button and the button name. So we can see that the button name is login, which we are going to specify, and then we're going to equal that to submit. So we can do it like this. Again, we need to separate it with this sign right here, and we type the name of the button, which is login, and then equal to the type of the button, which is in our case submit. So we equal that to submit. And these three steps right here, which is username, password and button, are enough for us to actually submit a request for a specific username and password. But we also need to differentiate a valid username and valid password from the incorrect username and incorrect password. So how are we going to do that? Well, luckily Hydra allows us to specify something that will stick out once a password is incorrect. And if we go to our page and we specify the incorrect username and incorrect password, once you click on login, you will notice that down here we have this string that says login failed. Now, just by thinking, we can figure out that this string will not exist if we manage to log in with successful credentials. So we can specify this string to our Hydra command to search for it, and every time it finds it, it will not print out that username and password as valid username and password, because they are incorrect. So we can specify it with two dots and then paste it right here. Login failed will be the string that we are searching for, which will indicate that the username and password is incorrect. After we specify this, we can exit out of the double quotes, and all we're left to do is to specify -l and then the list for the usernames, which we are going to call usernames.txt, and -p, which will be the list for the passwords, which we are going to call passwords.txt. Now for these lists you can use any type of list that you want. In my case, since we don't have them, I'm just going to create them real quick for the purposes of this tutorial. I need to make sure that I'm in the same directory where I'm running this command, and then I'm going to nano usernames.txt, and I'm going to type right here root account admin, then lowercase admin, password as a username, test123, and bunch of other things we are not going to specify. We can just leave it to be this small, just so we don't waste too much time brute forcing that page. And here we can type test123, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we can type admin, root, password, and password 1, 2, 3. So we do have the correct username and the correct password inside of both of these lists. Now that we have this, what we can do is we can run our command. Let's just double check it real quick. So Hydra, the IP address of our target. We're using the HTTP form post because we're sending a post request and we're sending our username and password inside of a form. Then we open double quotes and the first argument is going to be the path to the page that the login form is located in. The second argument is going to be username, password, and the button that we are submitting the username and password with. And the third argument inside of double quotes is going to be a string that we get once we specify the incorrect username and password. After it, we just specify -L for the usernames list and -P for the passwords list. If I click enter, and here it is. It managed to find the correct username and correct password. It printed it out right here and it tells us that the username is admin and that the password is password. So it finished relatively quick, but it only had around 49 login tries as it says right here. So you can feel free to use a bigger password lists in order to give this even higher chances to work. Now that we did this, let's give it a try and let's log in with the username and password that we got, and it indeed works. So our tool successfully brute forced the login. Now, in the next video, we're also going to take a look at how we can brute force this page right here, which is the brute force login page inside of our DVWA. Welcome back. Let's continue with our brute forcing of DVWA page. So we successfully brute forced the welcome login screen, but now we also got this brute force page right here that also requires username and password. Now this is pretty much the same thing, just this is a different page, so the syntax of the Hydra command will be different. Of course, if I were to type admin and password right here, it would still work. It would tell me welcome to the password protected area admin. But if I were to type something like test and then test, it would not work this time. So we must craft a specific command just for this page. If we were to use the command that we used from the previous video, which is this one, it would not work because it is not the same page, it is not the same type of HTTP form post, and it is also not the same type of fields. So let's clear the screen right here and let's start crafting our command. We're going to start with the same, which is Hydra and then the IP address of our target machine. Remember that in the previous video we used HTTP form post because our usernames and passwords were sent with post request. This time, if you take a look at the link right here, we can see that the usernames and passwords are being sent inside of the link. And this is a good indication that this is a GET request. Of course, you can also check that by visiting the page source, finding the form where you submit usernames and passwords, and here it is. And under the form, we can see that the method is GET. So this time, we cannot use HTTP form post, we must use HTTP GET form. So this is the syntax once we're sending the GET request. The next step is, remember, we open the double quotes, and in between the double quotes, the first argument is specifying the path to the page. So we must go right here, let us close this, and let's just refresh this page, just so we can get the path to it. So I'm just going to go right here, and we get the path to the page, which is going to be /dvwa, /vulnerabilities, /root, and / at the end. Copy this and specify it as the first argument right here. And remember, once we do that, we separate the second argument by typing 2 dots. And now comes the part where we specify the username, password, and button field. So let's go to the page, view page source once again, and let's find the name of the username field first. Here is the form. The first part is the username field, and its name is just username. So let's go to our command and type username equals upper arrow, user upper arrow. We separate the username from password with this sign. let's go and check out what's the password name. It is just password, and let's do the same as in the previous video. Pass, upper arrow, and the last part is the button, which we can even get from the link itself. So if I type hello as username and world as password, we can see right here in the link that the button login equals login. So we can just copy this, go to our command and paste it right here. And the last argument inside of the double quotes is, if you remember, we must specify what is the string that we get once we specify the incorrect username and password. And we can see it right here. It says username and or password incorrect. So let's just copy this and let's paste it right here. Great. Now if we go outside and specify -l and then usernames.txt and -p for the passwords.txt, if I press enter, you will notice that it will not work. It will tell me that every username and every password is correct. Sometimes when this happens, you haven't specified enough arguments. Either you have a syntax error inside of your command, or you didn't specify something well, or you're missing additional arguments such as the cookie value. So sometimes we must specify the cookie value also in order for this to work. Let me show you what I mean. To specify the cookie value, we must go right here, and before closing the double quotes, we're going to add another argument. So separate two dots, and we can type h-cookie, two dots, and the cookie value right next to it. How do we get the cookie value? Well, we get it with the help of burpsuit. So let's find the HTTP request where we send the hello and world as usernames and passwords, and let's see what cookie do we have right there. So let's go right here, let's try to find it. It is right here, /dvwa/vulnerabilities. Let's just find the correct request. And here it is. Here we can see inside of the link that we're sending hello as username and world as password. And the cookie that we have is this right here. So we want to copy all of it, including the security equals low, and including the PHP session ID equals, and then our cookie value. So copy that, go to the command, and right here you can paste the cookie value. So after the two dots, h-cookie, two dots, and then the cookie value right here. If I try it once again, well, now it works. Now it tells me that the username is admin and that the password is password. Just keep in mind that sometimes Hydra doesn't really make a difference between capital and lowercase letters, that's why we got two results right here. But it gave us the correct username and the correct password. So once you notice that the brute force doesn't work, try adding this cookie value and then it might actually work, because if you remember, once we didn't have it, it gave us that all of the usernames and all of the passwords are valid and that we can log in with all of that. So the difference, once again, between this and previous command is inside of this HTTP GET form, because we are sending with the GET request, then we have the different link, the username and password fields are the same, and the string that we get once specifying the incorrect password is also different. And here we also specify a cookie value, which we didn't have to specify in the previous video. Okay, great. Now that we covered the Hydra tool, in the next video I will show you a way how you can perform brute force much easier with the help of burpsuit tool. See you there. Welcome back. And in this video I want to talk about another cool feature of burpsuit that could allow us to perform the brute forcing of a login page a lot more easier than we did with Hydra tool. So burpsuit, besides you being able to inspect all the packets and intercept the packets and change them, you can also do some other cool things as well. And one of those cool things is brute forcing a login page. Now this is something that we're going to perform with the community version, and the community version of burpsuit has some limitations. The brute forcing will not go as fast as if you, for example, had the pro version, but nonetheless, let us see how it would look like. So let's go and visit the login page of our DVWA. if I navigate right here, and here we must log into our DBWA. The first thing that we want to do is we want to specify any credentials right here, for example, test and test. And once we click on login, this request that we just performed on our DBWA page will be saved inside of our burp suite. So under the targets, we got our target machine right here. And if I find the packet, here it is. Here is the packet that we sent. So we send the post request and we send our username of test and password of test to the target web page. Now, what we want to do in order to perform the brute forcing attack is we want to first right click on this packet, which we use to send our username and password, and we want to send it to intruder. Click on that and you will see this intruder bar light up. You want to navigate to the intruder, and here there are some options that we want to set before being able to brute force a web page. So here under the target tab, there is nothing that we want to change. Let us just move on to the positions tab, and in the positions tab you will see this request that we just sent. You will see some of the fields that are already selected, and you will see this attack type bar up here. The first thing that we want to change is we want to change the attack type from sniper to cluster bomb. And what this simply means is, since we're going to brute force both username and password, we want to be able to send both of them at the same time, and we can do that with the help of cluster bomb. If you, for example, knew the username and you just wanted to brute force the password, you could select right here sniper, and then you could just brute force a password. Right now we're going to go with the cluster bomb, and here we got 5 fields selected. Now, we don't need all of them, we only need the username and password field selected, so what we can do is we can click on this clear button. It will unselect all of these fields, and then to select the fields that we want, we can just double click on the field. For example, username equals test, I double click on test, it will select it, then I click on add, and I do the same for the password, select it right here, and I click on add. This will select just username and password, and once we do that, we can navigate to the payloads tab, where we're going to see a bunch of other options that we can also set. So under these payload sets, this will be the payload set for the username, and if I select this number 2, this will be the payload set for the password, because those are the only 2 fields that we selected. If I go with the username first, I change right here to 1. I will select the payload type to be a simple list, because we're going to brute force with a list. And under the payload options, I want to load that list. So I just click on this load button, then I can find usernames.txt, and you can see by default it will load all of the usernames from that list. Now I can delete this empty field, we don't really need it, and once I do that, once I load the usernames list right here, I can change from 1 to 2. And now I leave it once again on simple list, and here I want to load the passwords.txt. So once again I find the passwords.txt, and it will load all of the passwords from that file. Once all of that is ready, that would be pretty much it. We are ready to start our attack. So if I click right here on start attack, it will tell me that the community edition of Burp Suite contains a demo version of Burp Intruder, so some functionality will be disabled. We already knew that, so let's just go and click on OK. And this will start our attack. Down here we can see the progress bar as to how fast this goes, and you will notice it goes a little bit slower than the Hydra tool, but nonetheless it is still brute forcing our page. Let's wait for it to finish. And it has finished, but it seems that we didn't get any results right here. And by the way, inside of the intruder, how we can search for results is you can see all of the combinations of usernames and passwords right here. We can see the status, and we can also see the length. Now, the length for the correct username and password will in 99.9% of cases be different than the incorrect usernames and passwords. And in this case, it seems that all of them have the same length, so for some reason it didn't manage to find our correct username and password. Now, that could be due to many reasons, but if I just select one of the combinations and I go to the response, we get the 302 found. If I scroll down inside of the response, it doesn't give us any HTML content. This usually means that it is performing redirection. And if I go to our options inside of our intruder. All the way down under the options, we get follow redirections, never. So what I'm going to do is I'm going to check this on always, and I'm going to start the attack once again. Click on OK. And now we can see it has different type of length. Now all we need to do is wait for the combination of admin and password, and hopefully this time we're going to get different length of the response for the correct username and correct password. So let's wait for this to finish. Okay, so it has finished, and let's scroll all the way down. We can see every response has the length of 1638. And if I scroll down here, we can see that the combinations of admin and password, both capital and lowercase, have different length. This is a pretty good indication that these are the correct usernames and correct passwords. We can also see that it did indeed perform the redirection, as we can see multiple requests and multiple replies right here. So that would be about it. This is a simple way that you can perform brute forcing with the help of burpsuit. Now, I'll still prefer the Hydra tool due to it being a little bit faster than the burpsuit intruder, but this one, however, is easier to perform, since for Hydra you need to perform different type of syntax and sometimes it might not work, while this is just setting some of the options, selecting the fields and running the brute force attack. Now that we finished this, in the next section we're ready to start our coding projects regarding the web application penetration testing. See you there.
Okay, time for another coding project. After a long section of covering web vulnerabilities, let's see how we can test some of them by using our own tools. For this, I have decided to show you two different projects. Now, both of them are going to be rather small and they work rather similar, so once we create one of them, we won't have any problem in figuring out how the second one works. These two projects are going to be login page brute forcer and directories brute forcer. In the first one, we're going to try to break a login password by only knowing the username, and in the second program, we're just going to see whether we can find some hidden directories on a web page, and maybe those directories could be useful for us. Nonetheless, both of these programs are going to work similar. Our login brute forcer is going to open a txt file with a bunch of passwords, and we're going to send each one of those passwords from the file in hope that one of them is the correct one, which will grant us an access to that account. The second program is going to work by opening a txt file and reading common directory names that we will then request to visit, and if we manage to visit them and get status code 200, that means that page exists. If we get connection error, well, then that page doesn't exist. Nonetheless, enough of talking, we are already intermediate with our Python skills, so let's get straight into coding these two programs. See you in the next video.
Welcome back. In this video, we're going to be creating a brute force tool using our Python skills. So, in the previous section where we talked about web application penetration testing, we covered tools that are used for brute forcing, but this time I want to see whether we can create our own tool that will be able to brute force a login page. Now, before we even start, I want to mention that this tool will not be universal, so for every different page you will have to perform some minor modifications, the same way that we did inside of our Hydra tool and inside of our burpsuit. Nonetheless, let us see how we can create it. So if I type ls and navigate to my desktop directory, here we got the tools directory for our coding projects, and here I'm going to create the web app pen test directory. So I will navigate there, and currently this directory is empty. So let's nano our Python program. We can type nano and then bruteforce.py. Great. Now, there is only one library that we're going to need to perform this project, and that library is the requests library. It will allow us to automate the process of sending the get and post requests. So let's just import it straight away, and let's start our program. So first thing that we must think about is what are the information that we need from the user of this program in order to brute force a login page. So we will need a URL link to that page, and we're going to need a username for that specific account. Then we're going to run a bunch of passwords onto that username, and if we manage to guess the correct password, great, we're going to print it to the screen. If we don't manage to find the password, we're going to print password not in list. Simple as that. So let's start with those information first. Let's create a variable called URL, and that variable is going to be the input value, which means that the user of this program can input which web page they want to brute force. Let's open double quotes and specify that to them. Let's do it like this, enter page URL. Here they can enter the page URL, and right after we do that, we can create another variable called username, and this variable will do the same thing, so it will be the same input value, just this time we're going to ask for the username. So let's just type enter username for the account to brute force. And this is pretty much it for now. Now later we are going to add some other information regarding this project, but for now we only need these two variables. So how are we going to approach this? Well, first, since we have the URL and the username, we can start with opening a file that will contain the passwords that we're going to use to brute force. So we can do that with open, and we can call that file passwords.txt, and this is also something that we can ask the user, for example, input the name of the password file to use, and that would actually be a good thing. So what I'm going to do is, this is another information that we're going to ask from the user, which is password file equals input, and then enter password file to use. Simple as that. Let's not forget the single quotes, otherwise this will throw us an error. And let's close the brackets at the end. Now we can open that file by specifying password file, and we want to open it for reading. So we can specify just R between the single quotes, which means opening file for reading text. Now here we need to specify how we want to open it, so with open password file as passwords. That is how we're going to call our file object. Then we're going to enter a function, which I'm going to call cracking, and this function doesn't exist, we will have to code it, but nonetheless, this function will perform the brute forcing. This function will take two arguments. The first one is going to be the username, of course, that we specify at the beginning of the program execution, and the second argument will be the URL. Great. Now that we got this, we need to create the cracking function, and we're going to do that right here. So define cracking, and we specify username and URL as the arguments that it needs. So how are we going to do this? Well, we already mentioned that we are going to perform reading of the passwords. So for each password in this password list, we're going to try to send a request to that page with that password and the username. And if the response contains some valid argument that we have a valid username and password, we're going to print it to the screen as the correct username and password. And if we get something like login failed or something like that, we're going to move on to the next password. So how are we going to do that? Well, we already opened the file for reading that contains our passwords, and now what we can do is we can type for password in passwords, and remember passwords is our file. Then for each password inside of that passwords file, we can first strip it out of any additional characters using the strip function, so password will be equal to password.strip. This will remove any, for example, empty characters or something like that might cause us a problem in brute forcing this page. Then once we do that, we're going to print to the screen trying and then the password that we're currently trying, just so the user of the program can see which password is it currently trying to brute force. Once we do that, we need to send the request to that page. So how can we do that? Well, in this case, since we're going to brute force as usual, our dvwa login page first. If I log out, we know that this is being sent with post form. So the method of sending the usernames and passwords is post, and we can check that once again just by finding the form, and we can see that the method is post. That's why inside of our code we're going to type requests.post, and we're posting, and this request.post takes two arguments. In our case, the first one is going to be the URL, which is logical because we need to tell our program where you want to post that data, and the data that we want to post will be equal to this, data equals data. Just, we don't have the data yet. We need to tell our program what is our data. So how can we do that? Well, we can go right here and define data, and data has to be a dictionary. Inside of this dictionary, we have a key and the value, and we need to specify all the information that the program needs in order to perform a successful login. And that information will most likely be the username, the password, and the button that it has to click. Remember the same thing we had in Hydra tool. We need to click on this button in order to successfully submit the username and password. So how can we define it right here? Well, we define it like this: username, username, and this username is just the name of the field on our page, and this is the part of the program that you might need to change depending on the page that you're brute forcing. If the username field on the page that you're brute forcing is called something like user, then you must change this to user. And this right here is just the username that we're sending, which is the one that we asked the user of the program to input at the beginning of execution. The same thing we must do for passwords, and the reason why I'm already typing the username fields is because I already know that the name of the fields is username and password, because we already checked that in our web application penetration testing section. Okay, once we do that, we can do the same for password, and once again, we need to put the password into that password field, and the password will be this stripped value that we read from our passwords file, or from our passwords list. And the last argument that we need to specify is going to be the button. As you remember, once we send it right here, the button name is login and the type of button is submit. So we must specify it like that. Just this time, both of these values are going to be between the single quotes because none of them is an actual variable. So this is going to be our data. And in this requests.post, we're sending that data to our URL. And luckily our request library will perform everything else for us, so it will know where to put this data that we're sending. Of course, instead of just sending this data, we also want to store the response somewhere. So we can create a response variable, and that response variable will be equal to whatever the return value is from this requests.post function. And the return value is going to be the HTML page of the response. Once we receive the response, we have to check whether the password was correct or not. So how can we do that? Well, we can do that the same way that we did inside of our Hydra. Remember that in Hydra we had to specify the string that occurs once we specify the incorrect username and password, which is this down here, as we can see login failed. Well, we can do something similar inside of our program. Let's ask the user of the program first. We can create a variable, login failed string, and we can ask the user enter string that occurs when login fails. Simple as that. And once they enter the string, hopefully they enter something like failed or login failed. They don't have to enter the entire thing, they can just enter failed, which occurs on this page once you specify incorrect username and password. Then what we can do is we can check whether we find that string inside of our response. Now, to do that, we must type the if statement. And if statement will be something like this: if login underscore failed underscore string in response.content.decode then we have the incorrect password. And the reason why we're decoding this is because otherwise it won't be able to find this value inside of our content. So we must decode it first, and then it is basically searching for this string inside of the HTML page of the response. If it finds that string, that means we found the incorrect password, because that occurs only when it is incorrect. That's why we're just going to pass, we're not going to do anything. And if it doesn't find, which would be the else statement, then what we can do is we can print found username, and we can plus the username, and we can print the same thing for the password. So found password and plus password. So this will print the current username, which is always the same, and it will print the current password, which is currently in this iteration of this loop, which will be the correct password because it didn't find this string inside of it. After we find it, we can just exit the program. There is no need to continue brute forcing, so we can just exit out of the program. Okay, now that we did this, let us see whether this works. So if I go down here, and once we finish the cracking of the function, we can also print at the end, in case it doesn't find anything, password not in list. So we can just do it like this. Once it finishes the cracking function, it will go to this statement and it will print password not in list. If it finds the password, it will go to these statements right here and it will exit out of the program, so this will never get printed. Let's give it a try to see whether this works. So if I Ctrl-O to save, and the first thing that I want to do is I want to copy the passwords.txt file that I got on my desktop to the home Mr. Hacker desktop, tools, and then web app penetration testing. And if I ls, here we're going to have our passwords.txt file. And since this seems to be an incorrect passwords.txt file, I'm just going to delete this and I'm going to create a new one. Not really sure where is the last one, but let's just create it real fast. So the passwords can be something like test 123, 123, 4, 5, 6, 7, password 123, admin, root, and then the correct password. So we're just going to write password right here. And let's also write the password for the Gordon account, just so we can test two different accounts. And let's write another incorrect password at the end, which could be ABC. Okay, this is just the test example of the program, and let's Ctrl-O, and let's Python 3 our brute forcer.py. So the first argument that it asks is the page URL. So what we can do is we can visit that page, copy the link to that page, and paste it right here. http://192.168.1.2/dbwa and then /login.php. Click enter. It asks for the username for the account to brute force. We're going to use admin. The password file to use is passwords.txt. And make sure if the password file that you want to use is outside of the directory of your program, you will need to specify the entire path to that file. Once we do that, let's click enter, and it asks us for the string that occurs when login fails, and we can just type login failed, because that is what occurs on our page right here. For different pages, this will be different. Press enter, and it found the correct username and correct password. And it did it really fast. It tried these 7 passwords, none of those worked, then it ran onto the password and it printed out found username and found password.
Are you scared?
Let's also try for the Gordon just to make sure everything works. So I'm going to paste the link, or just type it in. The username is this time going to be Gordon B. The passwords file is going to be passwords.txt, and the string is going to be once again login failed. Press enter, and it also finds the username and the password for that account as well. Great, our program works. But let's also see how would we be able to brute force the inner page of this DVWA program or application. We also got this brute force page right here. But this is something that we'll have to brute force differently. Why? Well, first, it requires different type of request. It requires the GET request. And the second thing is this can only be brute forced within a current session. So if we are not logged into this page, we cannot even access this brute force page, and therefore we cannot really brute force. So we must also see how we can send this session inside of our program so we can be able to brute force this username and password. Let's give it a try. If I go to our program and nano the bruteforce.py, first thing that we must specify, as I already said, we're going to need to specify the session, so we need to ask for the user for the cookie value of that session. And they can just read it from the burp suite, just like we did once we covered our Hydra tool, so we can specify right here, enter cookie value. And this can be optional because we don't need it always, just like we didn't need it currently. But if they're brute forcing something within a session, then they must specify this as well. Now, what we can do is inside of our cracking function, right above the if statement, we can write another if statement. So if cookie value is not equal to an empty string, and if it is equal to an empty string, that means that the user doesn't require the cookie value, and in that case it will not send the cookie value and it will just brute force without the session. If it is set to something, then we're going to send the cookie value inside of our request. So in this case, if response, if cookie value is not empty, that means we must send it. So the response will be equal to requests.get, and this time we're using get because inside of this page our form is using the method get. That's why this time we're using the requests.get. This is something that you want to change depending on the page that you're brute forcing. So requests.get, and the first parameter is going to be the URL. The second parameter, we're going to set our parameters, which we specify like params, and those params are going to be equal to, once again, a dictionary. And that dictionary will be rather the same like this, just a few minor changes we're going to set. So copy this and we're just going to paste it right here. The first change is under the button. So the username and password field are named the same, like in our last page. As we can see right here, inside the form, the name for the username is just username and the name for the password is password. But the login is not the same. We got the value for login to be login and the name for login to also be login. So we can set it like this: login and then 2 dots and once again login. And the last parameter to this function, or the last argument to this function, is going to be cookies that are equal to a dictionary of cookie value, 2 dots, and then cookie value variable. And you can read the name of that field by going to your burp suite, and once I, for example, specified test and test123 as our username and password here, and then I go and find that request inside of our burp suite. Let's find it real quick, and I believe it is this one right here. Yeah, here it is. We can see that the cookie field is named just cookie. That's why we specified right here as cookie between the single quotes, and we paste the cookie value to that field. Once we do all of that, we have all of our parameters to this function, and this seems to not be able to fit inside of my screen, but it doesn't matter, it is there. And all we're left to do right now is create the else statement as well. And the else statement is going to be else. In this case, we don't have the cookie value, so we can just copy this part of code and paste it right here. And now we can delete it from here because we no longer need it. So this program is pretty much only used to brute force the main login page to the DBWA and this brute force page inside of the DBWA. You will need to adjust a few things right here once trying to brute force a different page, such as for example the name of the fields, the name of the cookie, and you will also have to adjust whether it is a GET request or a POST request. Everything else I believe can stay the same. Now that we got our code ready, let us see whether this works. So if I save this and I go and try to run this, let's first of all try once again to brute force the main login page by typing dbwa/login.php. The username is going to be admin, the passwords file is going to be passwords.txt, and the string that occurs is going to be login failed. Cookie is going to be optional, so I'm just going to press enter because I don't need it for the main login page, and it will still manage to find it. But let's see whether it will manage to find the correct username and password if I use the cookie value and if I brute force inside of this session. Let's give it a try. I will enter the page URL, and the page URL is going to be the URL to this page right here, which is this one. So let's copy it, paste it right here, press enter. The username is going to be the same, so it is going to be admin. The passwords file is going to be the same. The string that occurs is not going to be the same, so let's give it a try and see what happens once we send hello as username and hello as password. We get username and or password incorrect. Now, we don't need to specify this entire statement. We can just specify incorrect. And if it just finds the incorrect, that means we specified the incorrect password, therefore it is going to go on to the next one. So let's press enter, and the cookie value is something that we can read from our burp suite. So let's find the request that we used to send hello and hello as username and password, and here it is. All we need to do from here is find the cookie field and copy the cookie value. So security equals high, and the PHP session ID is set to a random value. All we need to do is paste that right here and press enter. This will start the brute forcing of our page, and you will notice that this time it goes a little bit slower because we're brute forcing inside of a session. Let's see whether it will manage to find once it gets to the correct username and correct password. Let's give it a few seconds, and here it is. It worked successfully. We found the correct username, which is admin, and the correct password, which is password, and now we can use that to log in to this page. As it says, welcome to the password protected area admin. So we successfully coded a brute forcer. Now you can perform some minor changes to make it even better, such as for example importing from term color, import the function colored, and this will allow us to print everything in a different color. For example, let's go down here, and this first print statement we can print like this, colored, and at the end we specify inside of the, for example, let's print this in red. We close two brackets, and once we also find the correct username and password, we can print this in green. So print colored. At the end we add comma and then green, and we close two brackets. Same thing we can do right here. And let's not forget the colored function right here, so colored. And now if we run this, python3 bruteforcer.py, let's use the regular main page, which is dbwa/login.php. Admin is the account, passwords.txt is the file, and failed is going to be the string that occurs. And it is even better, right now it prints the incorrect passwords in red color, and once it finds the correct username and correct password, it prints it in green. Great. We coded our project, everything works perfectly, just don't forget to change certain values inside of our program once you try this on a different web page. The two main things that you need to keep an eye on is the name of the fields inside of our source code. So you just find the form and you see how the fields are named. Then you use that inside of your dictionary, and the next thing that you need to pay attention to is the method that is used to send these usernames and passwords, whether it is a get method or post method. And at last, you also need to check the name of the button. So this can basically be named anything. That's why you always need to view page source and check it out before running your program. Great. Thank you for watching this coding project. We're getting better and better in Python, and in the next lecture we're going to create another small project in Python that will be used to brute force directory names inside of a web page. This will be a smaller program than this one, but nonetheless it will still be a useful program that you will use in your penetration tests. See you in the next video. Welcome back. Let us code our second project for the web application penetration testing section. So, in the previous video we took a look at how we can create a simple brute forcer that will be able to brute force both of our DVWA login pages. We made the post request, we also made the get request, and we also changed fields accordingly to each one of those pages. Now, as I already mentioned, that program you will need to adjust for every page that you brute force. However, this program that we're going to create right now, which is the directory brute forcer, you won't need to adjust for different pages, it will work for every page. And what a directory brute forcer is, as we already mentioned, it will discover some hidden directories that could possibly be useful to us once performing web application enumeration. So this is something similar as a derb tool that we covered in web app penetration testing section. So let's get straight into it. I'm going to open the terminal and I'm going to navigate to our desktop and tools directory. Here we got our web app penetration testing directory, and right here inside of this we got our previous project. Let us now nano a program that we can call directories.py. As the previous program, this one is also going to import the requests library. And before we start coding it, let's first think how our program is going to look like. So we're going to ask the user of the program to specify the target URL or the target link. Then we will open a file that has common directory names. We will read from that file, and for each directory name, we're going to perform a request for that page. If we receive a response or if we manage to load that page, that means that directory exists on that page. If we get something like a connection error, that means that page doesn't exist. So this program is really simple. Let's start coding it. And first thing, as we said, is going to be the target URL. This is going to be equal to the input value, as usual. And here we can specify something like this. And then enter target URL. What we also want to ask from the user is the file name, so file underscore name is going to be equal to input, enter name of the file, containing directories. Okay, so these are the only two things that we need. After we get them, we can open our file like this, so file equals open, and then the first parameter is going to be the file name, which they specify, and the second parameter is going to be opening file for reading. And this is something we already covered, so you should be pretty familiar with how we open files. As soon as we open file, we can start reading different directory names and requesting those pages. So for line in our file, for each and every directory in our file, we're going to first strip that line from any additional characters, and we're going to store that inside of the directory variable. So directory will be equal line.strip. After that we can create a full URL variable, and the full URL variable will be equal to target URL plus and then slash and then plus our directory. So what we are essentially doing right here is, let's say the target inputs a website link or a domain name of google.com. Let's say they input that, and from our file we read the admin directory. Essentially what we are doing right here in this line is we're combining these two like this. So this is how we search a directory on a certain domain. We simply just add a slash and type the directory name. Now that we got the full URL variable, we can perform the same thing from the previous video. Response will be equal to request from full URL. And this request function we don't have. It is not request.get or request.post. It is just the request function that we're going to code right now. So go up here and type define request. This request of course takes the parameter of URL. And what this function should do is it should try to connect to that page that we're looking for. And if it doesn't manage to connect, we're just going to pass. So how can we do this? Well, we can type try, and then we can try to return from this function requests.get. And the reason why we're returning is because we're going to store the response inside of this response variable. So we're essentially returning requests.get. And then let's add http / and plus our URL. So it is going to essentially try to visit our URL. We're just adding it the prefix of http //. So like this, everything should work. If we manage to visit that page, we're going to return the value. And if we don't manage to visit that page, in case of requests.exceptions, .connection error, we're just going to pass. And let's not forget to add 2 dots at the end of the except statement. So in this case, we didn't manage to connect, therefore we're just passing, and the return value inside of this response will be nothing, since we're not returning anything. So how can we then check which one managed to connect and which one didn't manage to connect? Well, we can just type the if response statement. And what this if response means is, if there is something in response, then do the following statement. If there is nothing in response, then it won't do anything. So in this case, if we have something in response, that means the try statement worked and we managed to connect to that page. So we're just going to print discovered directory at this path, and we're going to print the full URL. Simple as that. And this is our entire program. Let's go through it once again real fast. So we import the request library, we ask the user of this program for the target URL, we also ask for the file name, then we open that file and we read each and every line inside of that file, we strip it from any additional characters and store it inside of the directory variable. Then we create a full URL variable that will be the combination of target URL / and the directory name. Then we request that full URL, and if we manage to connect to, we will return this value inside of the response variable. If we don't manage to connect, this response variable will stay empty, and then at the end we're just checking if there is something in response, print that we discovered the directory at this path. If there is nothing inside of the response, it will not print anything. So let's test our program out. I will save this, and all we need to do is Python 3 directories.py. We enter the target URL, so let's just go and see what is the IP address of our Metasploitable, and in my case 192.168.1.2. And the name of file containing directories. So we need this file. And luckily, inside of our Kali Linux, if I open a second terminal and I type locate dirb or derb, however you want to pronounce it, we go to the user share and then derb directory, type ls, we will have this word lists directory right here. If we change to that directory, so cd word lists and type ls, we will have a bunch of these txt files. And inside of this common.txt file are common names for different directories. So what we can do is we can copy this common.txt file inside of our home, Mr. Hacker, then desktop, and then tools, and then web app penetration testing directory. Once I go to that directory and type ls, we should have our common.txt inside of the same directory as our directories.py file. So now if I go right here and specify common.txt, press enter, this will go and search for every directory, and we can already see that it is discovering some of them. We got the slash directory, the slash dev, slash index, slash php, slash phpMyAdmin, and those are all the directories that it manages to find in the main directory of the metasploitable machine. Now, you can also specify subdirectories if you want. For example, if I run the program again and type 192.168.1.2/dvwa, and I type the same file name, which is common.txt, now it will search for the directories inside of the /dvwa, and we can see it is finding different directories than it found right here. And what you would basically do once performing this type of enumeration is you would try to find something interesting. You would go from each and every subdirectory and try to figure out if there is any interesting directory onto that page that maybe shouldn't be there. For example, if I run our program and I type the IP address /motil-idae, which is the name of one of the directories on our metasploitable, I press enter, and I also use the common.txt file, it will find a bunch of the directories, but there is a directory that particularly stands out, which is this passwords directory. So we can visit that link, which is 192.168.1.2, and then motil-day/passwords. And it will lead us to this directory, which has this accounts.txt file. If I click on it, well, it seems like we found some file that contains usernames and passwords. We got admin, the password is probably admin pass, and this could be something like a security question and the answer to the security question. So this would be a vulnerability of information disclosure, where it gave us some information that we shouldn't have the access to. And we would never know that this passwords directory exists if we didn't run our directories program, which discovered it, and then visited it and found out that there are accounts, usernames and passwords available for us to read. Okay, great. So we have finished 2 projects successfully. We coded the login brute forcer and the directory brute forcer. So we are officially done with web app penetration testing. And in the next section, we're ready to touch on a subject of man-in-the-middle attack. It is a really interesting attack that we can perform inside of a network, and in the next section we're going to see exactly how we can perform it. See you there. Okay, welcome to the man-in-the-middle section. This is where we can relax a little bit, since we covered all the important things that an ethical hacker must know. From scanning, from exploitation, to gaining access with Trojans and web application penetration testing. Now we can lay back and cover something that you won't need that much, but it is a cool attack that allows you to sniff information inside of a local area network. Now, in network penetration testing, this is something that you also want to try. In some networks, there will be protection that blocks this type of attacks. However, to this date, many home networks, schools and company networks don't have this applied. Anyway, before we actually get to run this type of the attack, let's first talk about how does it work. Let's start like this. Now, imagine a home network with many devices. Say we have 2 computers and also our Kali Linux machine inside of that network. Networks also have routers that route their traffic to different websites. And every time that you, for example, communicate with a web page, you do that through your router. You request a web page, and a router will forward your request to that server, and when the server sends a response to you, the router will send it to your machine inside of the network. But how does it know which machine to send to? How does it know to who to forward which packet? Well, let's explain it like this. Let's go back to our 3 machines and let's mark them with A, B, and C. All of these machines, including our routers, also have an IP address. So we can say A has 192.168.1.10, B has 192.168.1.5, our Cal Linux machine has 192.168.1.7, and our router has 192.168.1.1. Besides having an IP address, all of these machines also have their MAC address, and these two help them communicate with each other over the network. Our router knows who to forward the packets to, thanks to Arp Packets and Arp Tables. Now, we're going to talk about Arp Packets in just a second, but what I want to mention for now is that our router has Arp Tables that map every IP address inside of the network with their MAC addresses. Then it uses the machine's MAC address to forward the packet to them. We know by now that MAC addresses are unique, therefore by knowing them, you know the ID of that machine and then you can communicate with that machine. Now, let's explain those Arp packets. What are they and how they allow us to communicate with each other? Well, to explain this, I will remove one machine just for the simplicity. Okay, so there are two types of Arp packets. We have Arp requests and Arp replies, or Arp responses. Now, with requests, we find out what machine has what MAC address, and with Arp replies, we reply to that machine that asks the question with our response. A request would look something like this. Let's say machine A wants to communicate with our Cal Linux machine. To do that, it must know our MAC address, so it sends the Arp request to the broadcast address, which simply means every machine on the network will get that Arp request. And with that Arp request, the machine A asks who has an IP address of 192.168.1.7. And it also tells, send me your MAC address if this is your IP address. In this scenario, our Cal Linux machine receives the request and it gives an answer. It says, I am 192.168.1.7 and here is my MAC address. Now, this is just normal communication in any network. This is how machines and our router figures out to who they should forward a certain packet. However, there are ways that this can be abused. For example, what if I, from my Cal Linux machine, craft an Arp response and send it to machine A saying that I am 192.168.1.1, which is the router. We know that machine A uses router to communicate with the internet, therefore, once we send the machine A an Arp response and tell it that we have an IP address of the router, it will start sending its packets to us instead of the router. For example, let's say machine A wants to visit Facebook. In this case, it would send that Facebook request to us instead of directly sending it to the real router. Well, you might be asking, what now? We just managed to redirect the traffic of machine A to go to us, and now that machine won't be able to access internet because the packets are not being forwarded to Facebook or any other page that they want to visit. Well, not exactly. We can also send an Arp response to the router. In this response, we tell the router that we are the machine A. Now machine A believes that we are the router, and router believes that we are machine A. All we are left to do in this case is forward the packets to keep the connection going. So in this scenario, instead of communication websites going like this, instead we spoof the network and now the communication is being done like this. In this case, if machine A tries to visit facebook.com, for example, it will send that request to us, which we then forward to the router, and the router forwards it to Facebook. Like this, we can sniff the data if it is unencrypted, and we can also see what websites is machine A visiting. And this communication works both ways. Once Facebook receives machine's A request, it sends the response that comes to our router, and then, since router is also being spoofed, it thinks that we are machine A, and it sends back the response to us. Then we forward the response to machine A, so machine A has no idea that it is being spoofed since it is able to visit any pages and websites. This attack is called man-in-the-middle with the help of Arp spoofing. And of course, when we perform this attack and we spoof our router and targets, their Arp tables will look something like this. The MAC address of machine A changes to our MAC address inside of the router's Arp tables. And that is while it's being spoofed. Once we stop the spoofing, the MAC address changes back to its real MAC address. Okay, great. Now that we know how exactly the attack works, let's mention a few things that we might want to get once performing this attack. The goal of it would most likely be to overall be able to sniff the data going from other machines on the same network. We also want to be able to check out what websites are other machines visiting, and if possible, in case some communication is not encrypted, we would want to sniff passwords if someone tries to log in to some page. Just most of these things depend on which websites are they visiting. Nonetheless, now that we know theory behind the attack, let's see how we can perform it using different tools. See you in the next video. Welcome back. Let's start with our first tool that we're going to use to perform Arp spoofing and man-in-the-middle attack. Now, for this type of the attack, there are many tools out there that you can use to initiate this attack. Some of them are outdated, some of them are already pre-installed in Cal Linux. However, we're going to cover one of the most known tools, which is called BetterCap. It is a little bit harder to use, however, we're just going to cover the basics of it. So, let's open up our terminal, and since this tool is not already installed in Cal Linux, we must install it first. And my advice would be for this entire section to run all the tools as a root account. Now you might be asking why? Well, we're going to perform a bunch of different networking things, and some of the networking things could require root privileges. So some of the tools might not run, some of the settings might not work if we run it as a regular user inside of our Cal Linux. So let's real quick enter the root terminal, and to install our BetterCap tool, we can simply type the command apt-get install and then BetterCap. Press enter, press Y once it asks you do you want to continue, and now we're going to wait for the BetterCap installation to finish, and then we're going to enter its framework and perform mitm attack. Okay, it has finished. Now, there are two ways that we can run this attack. We can run it as a command by specifying a file that contains all of the BetterCap commands that we want to run, or we can run it inside of the framework. Now, for the first try, we're going to just type BetterCap to open the framework, and we're going to experiment with different commands in order to run this attack. And then after this, we're going to see how we can run it just from a terminal in a one-line command. Okay, so once you type BetterCap inside of your terminal, it will open the BetterCap program, it will tell you which version it is, and it will also tell us to type help for a list of the commands. So let's type help to see what options do we have, and right here we're going to see a bunch of available services that we can run with BetterCap. Most of these services are not going to run, as it says right here not running, and the only one that you will see running is events.stream. Now, you might already start to notice something interesting for us, such as for example this Arp spoof. We talked about Arp spoof in the previous video, and we know that this is the base of our man-in-the-middle attack. However, before we get to it, let's go a little bit up and check out the help menu. So these are the commands that we can use with BetterCap. We can type help and then some module name in order to print out more information about that specific module. We can also active, quit, sleep for a certain amount of seconds. We can set value, the same way that we do inside of our MSF console. If you remember, once we set values for certain payloads, we do that using this command. So we can assume that this is something similar as an MSF console, or at least it has similar options and commands. Now let's go down to these modules, and before we actually get to this Arp spoof module, let us take a look at this net probe module. If I simply just type help and then net.probe, this will give me the help menu and the description of this module. So as it says, it will keep probing for new hosts on the network by sending UDP packets to every possible IP on the subnet. In other words, what this module will do is it will discover all of the online hosts inside of our local area network. So what we can do is we can turn that on to start network host probing in background. Let's run this command as it tells us right here. Copy this, paste it right here, and let's press enter. And we can already see that it managed to discover some of the hosts inside of my network. These are the active IP addresses right here. The next thing that we want to do is we want to type the help menu for the arp.spoof module. So just type help arp.spoof and press enter. And we also get the option as to how we can run this module. But down here we can see some additional options, or as it says right here, parameters for this module. We got arp.spoof.full-duplex, we got arp.spoof.internal, arp.spoof.targets, and arp.spoof.whitelist. In this specific scenario, we're interested in these two, so the full duplex and the targets. The full duplex, if we read the description, if this is set to true, both the targets and the gateway will be attacked, otherwise only the target. And as it says right here, if the router has ARP spoofing protections in place, this will make the attack fail. So in some networks and on some routers, this attack will not work because more and more routers nowadays are starting to implement the ARP spoofing protection. However, if it is not enabled, if the protection is not enabled, then we can perform this attack. So what we must do is we can type set arp.spoof.full-duplex to be equal to true, or just set it to true. Press enter right here. And we also want to set the targets. Now, you can specify the entire subnet or the entire network, or you can do it like I'm going to do. I'm just going to select one target. And the reason why I'm selecting one target is because once you run this on the entire network, there is a lot of information going inside your terminal. And it is going really fast, so you don't even get to read it. Therefore, what I'm going to do for the purposes of this tutorial is I'm going to select the IP address of my Windows 10 machine that we're going to perform the MITM attack on. And then I'm going to set arp.spoof.targets to be equal to that IP address. Just like this. Once I do this, I want to start sniffing for the network connections. And we can do that if I go up here. We can see that there is a module called net.sniff. If I type help net.sniff, it will just say that this will sniff packets from the network. And the command that we use to start it is net.sniff. But before we actually start it, let's go and check out the parameters right here. The parameter that we want to use for this attack is net.sniff.local. As it says, if this is true, it will consider packets to this computer, otherwise it will skip them. Now, once we start the ARP spoof attack, all of the packets from our target machine will go to this computer, therefore this will be able to sniff them. Let's copy this and paste it right here. And what we want to do is we want to set this to true. After we get all of these settings ready, we can type arp.spoof and we can set this on. And we can also type net.sniff on. Press enter, and this will start sniffing packets on our Windows 10 machine. We can also see some of the queries that our Windows machine is making. And if I go and try to visit some web page, we can see that our target machine is querying Facebook. As we can see, the desktop machine initiated the request for www.facebook.com. And this will work for any other website. We can see the requests for twitter.com. And if they were to input a password to an unencrypted website, such as, for example, let's say that they want to connect to our router and go right here, and they type, for example, test and click on login. If we scroll a little bit up, we should manage to find the request where they send the password. And here it is. Here is the request where they send the password. We get the username test and the password is a hashed value, however, we managed to get it nonetheless. It will work for any website that sends unencrypted data. For example, onto this website called volweb.com, if I go to first link, which is this one, and I click on login, type username admin and password test, I click on login, and for some reason it seems that it didn't manage to get it. Let's just scroll a little bit up to see whether we can find it, and here it is. Here is the packet that we sent, including the username and the password. We managed to sniff it from our Windows 10 machine. Here is the username admin and the password test. Great. This is one way that you can use BetterCap. Another way that you can use BetterCap is if I exit out of this program, it will automatically start the ARP spoof and it will restore our cache for our one targets. And the way that we can run it with a command is we can just create a file called sniff.cap. And inside of this file, we can type the commands that we typed previously, which is net.probe on. We also want to select arp.spoof.fullduplex to true in order to also spoof the target and the router. And we also want to select arp.spoof.targets to the IP address of our target machine. After that, we set the net.sniff.local to true, which means only sniff the packets that are coming from and to this machine. And then we type arp.spoof on and net.sniff on. These are all of the commands that we must run, so all we need to do is save this in a file called sniff.cap, and then we can run the command bettercap-iface, and iface stands for interface, where we need to specify the interface of our machine. Since on Kali Linux, the only active interface that I have is ETH0. Once I specify that, all I need to specify is another option, which is -caplet, and then the name of the file containing our commands. And this will do everything that we just did automatically. So if I press enter, it will set all of the settings that we did, and it will start sniffing for different connections. For example, if I go right here and try to refresh Facebook, it will sniff that request to Facebook. And this is one way that we can perform man-in-the-middle attack. In the next video, we're going to check out another tool that will allow us to perform this attack that you might actually find a little bit easier to use. So thank you for watching, and I will see you in the next video. Welcome back. Let's cover another tool that we can use for man-in-the-middle attack. And this tool is called similar to the previous tool from the last video. This tool is called BetterCap, just without B. Now, unlike the previous tool, we already have this pre-installed inside of our Kali Linux machine, and this is a graphical interface tool. So it might be a little bit easier for us to run it, and let's give it a try. What we must do first is we must open the terminal, and as I already mentioned in the previous video, let's run all of this with root account. Now, before we actually start running this tool, I want to talk about another thing which is called manual packet forwarding. So sometimes some of the tools will not perform the packet forwarding for you. And if you don't do it yourself, sometimes even after performing the ARP spoofing and the man-in-the-middle attack, your targets will not be able to visit pages because you didn't allow packet forwarding. To always make sure that your packet forwarding is allowed, you can cat out the file at location /proc/sys/net/IPv4 and /IP_forward. Once you cat this file, you will either have a value of 0 or 1 right here. If you have a value of 0, that means that packet forwarding is not enabled, and in that case, you must enable it first. To do that, you can type echo 1 and you echo it into this location. So proc sys net IPv4 and IP_forward. And then you double check to see whether the value of 1 has been added to this file, and it indeed has. Now the packets are allowed to be forwarded. Once you do that, then you can start your tools. So to start the ettercap tool, all we need to do is to type ettercap -g. Oops, it says ettercap not found. Let's give it a try. Maybe it is not installed by default. Let me see. Unable to load ethercap. Maybe it is lowercase, so if I type it like this. Okay, so now it works. Just make sure that you specify it with lowercase e at the beginning. Then you type ethercap and then -G for graphical interface. Once you do that, it will open this new window, which is the new version of ethercap that is a little bit different than in the previous Kali Linux versions. You can enlarge the window, and the first thing that we must do right here is to set up the interface and the sniffing at startup. So you can turn this on. You can select your primary interface in case you're over Kali Linux. It will usually be ETH0. Unless you're running over wireless, then you want to choose a different interface, and once you do all of that, you can click on this check button right here, which says accept, and it will tell you down here started unified sniffing. Now, what I usually like to do is I like to enlarge this lower window a little bit more to see everything better, and then we can experiment with different ethercap options. The first thing that we must do once performing this attack is to discover all of the hosts on the network. To do that, you can type on this button right here. It will even tell you that this button is used to scan for hosts, and once you click on this, it will automatically scan all 255 hosts on my network, and it will tell me 4 hosts added to the host list. But right here we cannot really see the hosts, so how can we see which hosts are discovered? Well, we can go onto this button right here. Click on it, and it will tell us the IP addresses of the hosts and their MAC address. Down here, also these buttons will open. Delete host, add to target 1, or add to target 2. And as in the previous video, we're going to perform this attack on our Windows 10 target machine. Or in my case, I'm going to perform on my Windows 10 target machine. You can choose whatever machine that you want. Since the IP address on my Windows 10 machine is 192.168.1.7, I'm going to right click on this and add to target 1. To check out whether I successfully added, I can take a look down here, and it does say host and then this IP address added to target 1, but I can also go to these 3 dots, click on targets and click on current targets, and it will tell me that I have the current target of 192.168.1.7. Once I select my targets, I can start ARP poisoning, and to do that, I click on this right here, which says MITM menu, and we got different types of poisoning, but we're interested in this ARP poisoning. Click on that, and click on OK to start sniffing remote connections. It will tell us down here ARP poisoning victims, group 1, which is the only target that we specify with its MAC address, and the group 2 will be all of the hosts in the list, but we don't have any, so currently we're attacking just the Windows 10 machine. Now, there is one thing about this tool, it will not print nearly as much information as the previous Ethercap tool. However, once our target visits a page that sends unencrypted usernames and passwords, it will print that right here. And we can take a look at that by going to our router, as in the previous video, and typing in, for example, admin and then password. If I click on login, down here we will manage to sniff that. As we can see, the HTTP, it will tell us from where did the connection come from, the username is admin and the password is this. Now this is once again the hashed value of the password, because that is how it is implemented inside of our router. If it was some page that was sending the passwords in plain text, we would be able to see it right here in plain text. Okay, so now that we did the same thing from the previous video, I also want to show you a cool trick that you can check out to see if the target machine is being ARP spoofed. So let's say that we are on our target machine, and this is the machine that is currently being ARP spoofed. How can we check out whether our connection is being sniffed? Well, we can open the command prompt and we can type the command arp-a. And this will give us our ARP cache, or in other words, this will give us the IP addresses of the machines in the local area network and their correspondent MAC addresses. And if we take a look at right here, we can see that all of these IP addresses right here appear to have the same MAC address. And that is not a good sign. Once you see something like this, or if you even see two different IP addresses having the same MAC address, that is also not a good sign, and that would most likely mean that a man-in-the-middle attack is being performed, especially if you have an IP address of router having the same MAC address as a different machine on the network. And this is how you can check this out. For example, if I stop this, let's go right here and quit this program, stopping the MITM attack, and closing this. And if I go and run the same command, now you can see different IP addresses have different MAC addresses. And this is how it should be, because the MAC addresses are unique. So one IP address should have one different MAC address, and not like this where we had all of the IP addresses having the same MAC address. Now in the next video, we're going to take a look at how we can perform this manually using Python 3. We're not going to be sniffing for data, we're just going to see how we can change the MAC address of the router from our Kali Linux machine to appear as the same MAC address from the Kali Linux machine to our Windows 10 machine. Or in other words, if you didn't understand, we're going to spoof the Windows 10 machine with one packet just to change its Arp tables. And we're going to do that using Python 3. So that would be about it for the AtterCap tool. You can experiment with other options as well if you want to, and I will see you in the next video. Welcome back. In this video, we're going to take a look at a cool way that we can actually perform ARP spoofing or ARP poisoning manually. We're going to do that using a huge library that comes with Python 3, and that is called the Scapy library. Now, Scapy allows us to manipulate different networking packets, and we can also send and receive the packets as well. Now, we could do something like this with the help of a socket library, but that would be much harder, because with the help of Scapy we have all of the packets already predefined, and we can just craft them to our liking. Now, the same way that you can open Python inside of the terminal, you can also open Scapy inside of the terminal. And this will allow you to write the code line by line. So it will take a few seconds to open this framework, and once it opens up, you will see this Scapy banner, and then you will be able to run the commands right here. Scapy works similarly to Python, so you can use the print statements to print hello world, for example, and it will also run that code as well. However, we're not going to use it for this. We're going to use it to craft packets. For example, there are attr headers inside of a packet, and to see all of the fields that an attr header has, we can type ls and then attr. The same way we can do for the Arp packets. For example, if I type arp inside of the brackets, it will give me all of the fields that an Arp packet has. And you can do that for any packet that you want. For example, you can also do it for TCP packet, and it will give you all of the fields that the TCP header has. And then you can change each of these fields to your liking. But as I already mentioned, the goal for this video is for us to craft an Arp packet that will poison the Arp cache of Windows 10 machine, and that will tell our Windows 10 machine that we are the router. So how can we do that? Well, first, if you remember, we must know the MAC address of our Windows 10 machine to be able to send the Arp poisoning packet to it. Now, we're not going to cheat and check out the MAC address inside of the command prompt on Windows 10, we're going to get it using Scapy. To do that, we must send an Arp request that we request the MAC address of the Windows 10 machine. To do that, we must also send that request to the broadcast MAC address, which, if you remember, means that every machine on the network will receive that request, and then hopefully our Windows 10 machine will reply with its MAC address. So to do that, let me see if I can use clear command right here. Okay, great, I can use it. To do that, we are going to combine the attr header that we just checked out with the Arp header or the Arp packet. The reason we need the attr header is so we can specify the destination MAC field to be the broadcast MAC address. Therefore, our Arp packet will be received by anyone on the network. Let's do that. So let's create a variable called broadcast, and this variable will be equal to @header, and the dest field, which is the destination, we can set to the broadcast MAC address, which is for everyone 6 times FF separated by 2 dots. Once you do that, you can close the brackets, and now we got our broadcast packet ready. To check out whether everything is selected correctly, we can type broadcast.show. And this will show all of the fields that we have right here. And you will notice that it will automatically set the other 2 fields. This is the MAC address of our Cal Linux machine, which is the source MAC address because we are sending the packet from our Cal Linux machine, and the destination is to who we are sending the packet. In this case, we are sending the packet to everyone. Now what we must do is we must also create the Arp layer to this packet. And to do that, we can type ls arp first to check out all of the fields, and we want to target the Windows 10 machine because we want to get its MAC address. So what we must do is we must type the p destination to be equal to the IP address of Windows 10 machine. All the other fields will be set automatically for us, except this hardware destination field, which is the MAC address of our target, which we get from the ARP response. So to craft the ARP layer, we can type ARP layer equals and then ARP, and inside of the brackets we specify the fields that we want to use. In this case, we only specify the p destination to be equal to 192.168.1.7, or you can just specify the IP address of your target machine. Press enter, and before I explain this, I can just type arp.show to show you how the packet looks like. So it will select the hardware source to be our MAC address, it will select the p source to be our IP address, it will select the p destination to be the target's IP address, which in our case is 192.168.1.7, and the hardware destination will be empty because this is the value that we want to get back. This packet is essentially saying, who has 192.168.1.7, give me your MAC address. And to combine this packet with our broadcast layer, we can type entire underscore packet equals broadcast/arp layer. And this will put our 2 layers together. If I type entire underscore packet.show, you will see we have both the Ethernet layer and the ARP layer. Only thing we must do right now is we must send this packet to our network. We can do that using Srp function, and this function takes arguments of entire packet. We can also set the timeout to be 2, and we can set the verbose to be equal to true. Now, this is not something that we want to send. We want to store the response inside of the answer, because if the Windows 10 machine answers, we will have our answer with the Windows 10's MAC address right here in this variable. We also want to only get the answers and not the unanswered packets, and we can do that by specifying right here 0 to select the first element inside of the list. Once we do that, we can press enter, and we get operation not permitted, and that could be because we are not root account. So what I'm going to do is I'm going to run this real quick as root. So I'm just going to write all of the commands that we just did, and I will get back to you as soon as I get to the srp command. Okay, so here we are. Now we made a mistake that I already talked about. We must run all of this as a root account, otherwise some of these commands will not work. And I just typed all of the previous commands that we did, such as setting the broadcast layer, ARP layer, and creating the entire packet. Now we are sending the entire packet with this command, and we are storing the response in the answer variable. So let's press enter, and it will tell us finish sending 1 packets, received 1 packet back, and got 1 answers. Now to get this answer, it's a little bit tricky. So if I type print answer, we will get this response right here. And since all of these are empty, we want to select this other part right here and print just that part. To do that, we can type print answer and then the first element, which will be the answer packets. So in the brackets we specify 0, press enter, and this is our response from the Windows 10 machine. If we take a look at the response right here, we're going to see the MAC address of Windows 10 machine, so we successfully received it with our packet. Now, we can either copy it from here and store it in a variable, or we can select it like this. So we're going to print the answer, and from the answer we are selecting the first element, and from the second list we are selecting the second element, and we're going to type .hwsrc. And the reason we are using hwsrc is because this is the field that has the MAC address of our Windows 10 machine, or of our target machine. Then if I print this, it should print just the MAC address, and here it is. And all we need to do right now is copy this and store that in a variable that we can name target MAC address equals, and then our answer with the HW source field. Great, now we got our target's MAC address and we're ready to craft the malicious Arp packet. So what we can do is we can type something like this. The packet will be equal to Arp packet, and we're going to select the OP field to be equal to 2. Now if you type lsarp, you're going to see the OP field, and this OP field is simply just asking, are we sending Arp request or Arp reply? Once we select the field to be equal to 2, this means we're sending an Arp response. And remember, to send a malicious Arp packet, it must be an Arp response, telling the router that we're Windows 10 machine or something similar to that. Once we set the OP to be equal to 2, we must set the hardware destination to be equal to target_MAC_address. And from here, we are selecting 2 more fields, which are pDestination, to be the IP address of our target. So this simply means that we are sending this packet to our target. And the last part is where we add the malicious thing. Here under the psource, in a real packet, in a real communication, we would specify right here the IP address of our Kali Linux machine. But in this case, we want to pretend that we are router, so we're just going to specify the IP address of the router. And this, right here, is our malicious packet. If I type packet.show, you will see it right here. We have the MAC address of our Kali Linux machine, but we also pretend to be the router. We typed the router's IP address instead of our own, and this packet is being sent to this destination. Now, before I send it, I'm going to open the command prompt on my Windows 10 machine, and I'm going to run the arp-a command from the previous video, just to see how the Arp tables are currently being set. So we can see that the router, which is in my case 192.168.1.1, has this MAC address. Our Kali Linux machine, which is 192.168.1.10, has this MAC address. And you will notice, once I send this packet, this IP address, which is our Kali Linux, and the router's IP address will have the same MAC address. And that is an indication that the Arp spoofing attack is taking place at that specific time. So let's send the packet, and to do that we can use the send function. The first argument is going to be the packet, and we can set the verbose to be equal to false, and press enter. If I go back to command prompt and type arp-a again, we can see now router has the same MAC address as our Kali Linux machine right here. So we successfully Arp poisoned the Arp cache of our target machine. Now that we did this, you probably now fully understand how Arp poisoning works. And you can also take a look at different tools online to see if there are some better tools that you can use to perform man-in-the-middle attack. Some of them have more options, some of them have less options, but nonetheless, this is all it is about this attack. You simply just send a malicious Arp packets and redirect the connection to you. So thank you for watching this video, and I will see you in the next section. Welcome to our first bonus section of the course. In this module, we will be covering how to crack a wireless password. Now, this process can be complex because it requires a lot of tools to complete, but besides tools, it also requires something that all of you might not have, and that is a wireless card that supports monitor mode. Now, this is pretty much the reason why this is a bonus section. You need this in order to complete this attack, and not many wireless cards support monitor mode. And what monitor mode allows us to do is to sniff data from access points around us, which then we will use to sniff the hashed password once someone tries to connect to a Wi-Fi. Most of the wireless cards are being ran in managed mode, and managed mode is something you would normally use when you want to use Wi-Fi and surf the internet. However, some wireless cards have this monitor mode option, and I will show you in the next video how you can check whether your wireless card can be put into monitor mode and how to do that. Anyway, let's explain how the attack will work in greater details. So let's say we have a wireless access point, and this wireless access point has two devices connected to it. We also have our Kali Linux machine. However, Kali Linux machine isn't connected to the wireless access point. It only has to be close to it to perform this attack. Once we get close to our wireless AP, we turn our wireless card into monitor mode. Once we have it in monitor mode, we will be able to see all of the Wi-Fis around us as well as our target Wi-Fi. Once we choose out of all of those access points which one we want to attack, we need to identify two things about that access point. Those two things are the channel on which it runs and its MAC address. Both of these we will be able to see with our tools that we will use. Now, channel is just a digit and we already know what MAC address is. Right now that we got our information that we need, the next step is to capture the password. But how can we do that? For this, a device must try to connect to that wireless access point, right? Correct. And once it tries to connect, it will initiate 4 different steps, also known as a 4-way handshake, between the device and the access point. In those 4 steps, it sends the hashed password value to the access point, and that is what we want to sniff. However, it could be a long time until someone tries to connect to that Wi-Fi. So, are we going to just sit there and wait for someone to connect? Well, of course not. We're going to perform a different type of the attack to kick everyone off of the Wi-Fi, and that is called the authentication attack. Once we send the authentication packets, this will disconnect every device that was previously connected to that access point. The goal of this happens once we stop the authenticating. Then, those devices that got kicked off Wi-Fi a few seconds ago will try to reconnect back to that access point. And all that time, we will be sniffing for that 4-way handshake with our password key. And as soon as they connect, we will get that password value that we want. After this point, we no longer need to be close to that Wi-Fi access point. We can go on the other side of the world in order to crack that password. Now you might be asking, how? Well, we wrote the hashed password inside of a file. Therefore, it is on our PC, right? After this, all we need is a little bit of luck that the password is easy and not complex, and then we use that hashed password that we sniffed and we throw it into different tools that can help us crack this password. Most known tools used for this are AirCrack and Hashcat. AirCrack uses CPU power or processor power to crack the password, while Hashcat can use both CPU or processor power and your graphics card power, and it can sometimes crack a lot faster than AirCrack. Now, the average speed of cracking passwords with these programs, depending on what CPU and GPU you have, would be around 300 to 100,000. And yes, of course, we're talking about 300 to 100,000 passwords per second. So this is a completely different story than, for example, brute forcing web login page or SSH or something similar. This is a lot faster. Now, of course, since we're running a virtual machine, the speed will be significantly lower, but compared to previous brute force attacks that we did, it will still be really fast. If the password is not complex and we manage to crack it, then you guessed it, we can connect to that wireless access point. And if we want, we can attack the devices inside that network with all the previous attacks that we learned. But that is completely up to you what you do after you gain access to the Wi-Fi. So now that we know how all of this works, let's see the practical side of it and let's crack a wireless access point. see you in the next video. Welcome back, and let's start with wireless hacking attack. So you will notice that I'm currently not on my Cal Linux machine. I'm currently using my laptop because my laptop has a wireless card that supports monitor mode. And in this video, I will show you real quick how you can put your wireless card into monitor mode, and if it works, that means it supports the monitor mode. If it doesn't work, well, that means your wireless card doesn't support monitor mode. However, in the resources, I will leave some of the wireless cards that are used for wireless hacking, and all of them support monitor mode. So if you really want to perform this attack, you can check them out online and you can get yourself a wireless card. Now, before I actually do anything, I'm going to zoom all of this in so we can see everything better. And the first thing that you must do is you must type the command ifconfig. And since this is also Linux, all of the commands inside of the terminal will work the same as we learned. And now here we can see we got three different interfaces. I got the ENO1, the loopback interface, and WLO1. And this is my wireless card. It is called WLO1, and for you it might be called something different. However, the process of putting it in monitor mode is rather the same. First thing that you want to do is you want to type iwconfig to figure out what is your wireless card. Just to make sure, I typed iwconfig and it told me that WLO1 is my wireless card. It is connected to this ESSID, and what ESSID means is just the name of the wireless that it is currently connected to. And here we can see the mode that I talked about. You will notice that this wireless card is currently in managed mode, and this is the regular mode that all of the wireless cards are once you try to connect to a wireless access point. To put it in the monitor mode, what you want to do is you want to type ifconfig, then the name of your wireless interface, which in my case is WLO1, for you it might be different, and you want to put it down. How do you do that? Well, you simply just type ifconfig WLO1 down. You won't get any output, however the next command that you want to run is iwconfig WLO1 and then mode monitor. You press enter, and the third and last command is putting the ifconfig up. So you just type ifconfig WLO and then up. Now your card should be in monitor mode. To double check it, you can type iwconfig, and now you can see that WLO1 is in monitor mode. This is how you can put your card inside of the monitor mode. And you will notice as soon as you do that, sometimes you might get disconnected from the internet. You will not be able to access the internet inside of the monitor mode. And sometimes this will by default go back to the managed mode, so if I type ifconfig or iwconfig once again, you will notice that it went back to managed mode. So sometimes you might want to perform this multiple times until you actually get it in monitor mode. However, this is how you put it, and in the next video, let's get straight into getting our hashed password from our target wireless access point. See you there. Welcome back. So we saw how we can put our wireless card in monitor mode, but right now let's get to the real attack. So the steps go like this. We want to put our card in monitor mode. We then want to sniff all of the information around us. Then out of all of the wireless access points, we must pick the one that we want to attack. And in this video I will be attacking my own wireless access point because attacking anyone else's would be illegal. So we'll be attacking my access point. You can attack yours if you're still following this section. And once we choose our target, we need to check out the channel on which the target is running on and the MAC address which the target access point has. Then we must run our sniffing program, and simultaneously while running that sniffing program, we must run our deauthentication attack. Then we can deauthenticate the devices on that access point for a few seconds, and once we stop deauthenticating, we should be able to sniff the 4-way handshake with the hashed value of the password. Then we can move on to the Cal Linux machine, and there we're going to try to crack that password. Okay, there are a lot of steps in front of us, so let's get straight into it. So what I'm going to do is I'm going to put my wireless card in monitor mode, as I did in the previous video. Nothing really to explain too much here. And the next command that I want to run right after it is airmon-ng check WLO1, which is my wireless interface. Now this program is something that you have inside of your Kali Linux machine, so you shouldn't have problem running this. The wireless interface is something that you want to change to the name of your wireless interface, and once you set the entire command, you can click enter. It will tell you that it found 5 processes that could cause some trouble. Now this means that if we run into any problems during our process of gathering the 4-way handshake with the password, it could be due to these processes still running. So we're just not going to risk that, and we're going to kill all of those processes straight away. How can we do that? Well, we can type airmon-ng and then check and then kill. Once you type this, press enter. It will also tell you that it found 5 processes, but down here it will also tell you that it is killing all those processes. So now we shouldn't have any problem running our other tools. Once you do that, what you want to check is whether your wireless card is still in monitor mode, and since it sometimes turns back to manage mode, you must put it once again into the monitor mode after performing the airmon-ng command. After you put it back to monitor mode, the next command that we want to run is aerodump-ng and then the interface that is currently in the monitor mode. Since WLO1 is inside of the monitor mode for me, I will press enter right here, and this will start sniffing all of the information around me. Let me enlarge this terminal, and we're going to be able to see all of the wireless access points that are around me. These are the names of the wireless access points under the column ESSID. The authentication and the cipher and the encryption is type of the protection that the wireless access point has, so you can see most of them will have WPA2, which is currently the highest protection they can possibly get. CH right here is something that we want to remember, because the CH column is actually the channel, and you remember channel is one of the 2 things that we must need in order to perform this attack. The data can tell us if the access point is active currently, or if it has some devices connected to it that are browsing the internet, while the beacons would usually tell us the same thing. However, the PWR right here can tell us how far away is the access point. So the lower the number, the closer the access point is to you. And sometimes if you choose an access point that is far away, this attack might not work. You have to be really close to the target in order for this to work. However, you do not have to be connected to the target. As you can see right now, I have no access to the internet, I am not connected to any access point, and I will be targeting this access point right here, called Pakmichar. This is my wireless access point, therefore I will be targeting that one. Now, remember that we need to remember 2 things. So the channel for my access point is 2. And by the way, once you choose your target, feel free to Ctrl+C this, because sometimes this screen knows to move and you cannot really copy and paste different things that you need. So I have chosen this target right here, and I need to remember the channel, which is 2, and the MAC address. Now the channel is easy to remember, so therefore I'm just going to copy the MAC address right here, and then we need to start the sniffing process again. However, we're going to write information inside of a file. For this, we're only going to sniff 1 access point information, and to do that, we must specify the channel and the MAC address. So we start the command the same, with aerodump-ng, then we use -c command for the channel, and we specify the channel number. In my case, that is 2. And aerodump is also a program that you have pre-installed in Kali Linux, so all of these programs that we use, you will already have in your Kali Linux machine. If you don't, or if you're using some other machine to perform this, I will link in the resources how you can download all of these tools. It is pretty simple, so you shouldn't have any problem downloading them. Nonetheless, let's get back to our command. So we got arrow dump -ng, then -c for the channel. We specify channel number 2. For you, it might be different channel. And after that, we use --bssid. And what bssid is simply the MAC address. Since we can see that the column where MAC addresses are is called bssid. So after this, we must paste our MAC address to our target wireless access point, and the last parameter to this command is going to be -w option. And this -w option simply stands for the file name that we're going to write all of this in. So let's call this the wireless access point name in capital _test. This is going to be our file name. And by the way, also once running this command, remember in which destination are you running the command, because that is where it's going to save your files. I'm saving this as _test, and the last thing that we must specify is the wireless interface, which is currently in monitor mode. For me, that is WLO1. You specify your wireless interface in monitor mode, and once you craft this entire command, you can press enter. And you will notice right here, it will only sniff for this specific wireless access point. We can see the name right here under the ESID, and we can see its MAC address. What also we can see are the devices that are currently connected to this access point. And at the moment, it only has 2 of them. Now what I'm going to do is I'm going to connect to the wireless access point over my mobile phone. And you can see that we already managed to capture the WEA handshake, which is all that we need in order to be able to crack the password. However, we're going to try to do that again, just by performing the deauthentication attack. Because we can't really wait for someone to randomly connect to our access point, we must disconnect everyone from that access point. And to do that, I'm going to enter the root terminal. And I will enlarge this, of course, so you can see everything better. And the command that we must use to actually deauthenticate someone is using the airplay-ng tool. So it is spelled like this, and the options that it takes is -0 and then space and 0 once again. This means it will send the authentication packets indefinitely until we Control-C the program, and then it will stop the authenticate. So what I advise you to do, if you're following this attack, is connect your mobile phone to the access point, and you will notice as soon as we start running this command, your mobile phone will get disconnected from that wireless access point. So once you type -0 and then 0, the next parameter is -a, and after -a comes the MAC address of the wireless access point. At the end, we only specify the wireless interface in the monitor mode, and we can start the authenticating. And if I take a look at my phone, I am instantly being disconnected from this wireless access point. And if I go to settings and try to connect back, it will not work. Nobody will be able to connect to this wireless access point as long as I'm running this attack. But you only want to run this for a few seconds. And once you run it for a few seconds, everyone will be disconnected. Then you Control-C. And here, in just a few seconds, we will be catching WPA2 handshakes with the hashed value of the password. From my phone, I already established connection to the wireless access point, and once you do that, in the upper right corner, you should see this WPA handshake, and as soon as you see that, you can Control-C this program. You got everything that you need. You got the 4-way handshake, and inside of that 4-way handshake is the password that you need. Once you finish all of this, you will notice that you got 4 different files on your desktop. As you can see, 1, 2, 3, and 4. And you actually only need 1 out of these 4 files, and this is the .cap file. All of the other 3 you don't need for this attack, so you can just save the .cap file and you can delete the others. Once you have the .cap file, inside of this file is our 4-way handshake, and then in the next video we're going to use different tools to extract the hash password from this .cap file, and then we're going to use massive word lists to try to crack this password from this file. But for this, I'm going to switch to my Cal Linux machine, so we can go back to our normal environment since I no longer need to run any program on my laptop. See you in the next video. Welcome back to our Cal Linux machine. So we captured our password from the wireless access point. We performed the deauthentication attack, we kicked everyone off of the internet, and then when we stopped the deauthentication attack and someone tried to connect back, we captured the four-way handshake into one of these files. And I transferred them to my Cal Linux desktop, and do you remember which one of them is important? Only this .cap file. All of the other three we don't need. Now you can delete them if you want to, I'm just going to move them on the side. And this is the file that we're going to use for both ways of cracking the password. Now open up your terminal first, and unlike any other brute force attack that we previously did with small password lists of tens or hundreds or thousands of passwords, this one is going to be a huge password list. This password list contains over 10 million unique passwords, and it is on our Cal Linux machine. So how can we find it? Well, you can type the command locate and then rocku.txt. This is the name of the password list. And we will see that it is currently in this location right here. So /user/share/wordlists and rocku.txt.gz. Let's go to that directory. And let's copy rocku.txt.gz to home, Mr. Hacker, and then desktop. Let's have both of the files at the same location. Now let's go back, and you will notice that this file has this .gz extension. This means we have to unzip it first, because this is a zipped file. Since it has .gz extension, we can unzip it using gzip tool. And to do that, we type gzip and then -d and then the file name. If I press enter, you will see that this file is so big that it actually takes a couple of seconds for it to get unzipped. And if I were to actually try to cat that file, well, you will see this will go on forever and ever. Now I can Ctrl-C this and nano that file if I want to make some changes or add some passwords, and you will also see that this takes a couple of seconds as well due to file being so big. Down here we can see it has 14 million passwords. All of these are some simple passwords that could occur in most of the cases when someone has a simple password, especially for wireless access points. For example, here is 123456789, we got password, princess, rocku, and some names right here. Basically, these are just some usual words that occur in passwords. Now, to crack this, now that we got both of these files right here, we're going to use the .cap file from our desktop and the rocku.txt wordlist. We're going to combine that with a tool called aircrack. Aircrack is also pre-installed in Cal Linux, so you just type aircrack-ng. And to crack the password, all we need to do is type -w and then the password list name. In our case, this is rocku.txt. And after it comes the name of the .cap file. So I'm just going to type the name of the file and then .cap. This is the entire command. If I press enter, you will see it will start cracking our password. Down here you can see the different phrases that it uses, such as current phrase. This is the current password that it is currently trying to guess. And here we can see the progress of all of the passwords. So by the time that I started this program, it already managed to scan over 10,000 passwords and compare them with our hashed password. The speed you get right here in brackets, which is currently almost 400 passwords per second. And here you get the total number of passwords that have to be tested. The time left is, at this current speed, how much time you have left to go through all of these passwords. And here you get the percentage of the entire password list, which we're currently at 0.15%. Now, of course, we're not going to be waiting for this. I can just go and check out whether the password is in this password list, or what I'm going to do right now for the purposes of this tutorial is I'm going to manually add that password to our password list. So I'm going to nano the rockyou.txt, and I'm going to scroll a little bit down to, for example, 400 or 500 password, and there I'm going to write the correct password to my wireless access point. And we want to see whether our program will be able to find it as the correct password with that speed of 400 passwords per second. So I'm going to stop right here, and let's type a new line, and here I'm going to add the correct password to my wireless access point, and it is this one right here. Now you should do the same thing, just scroll a little bit down through this password list and just write your password somewhere in the list, and you will notice that it will manage to find this in less than 1 second. So let's save this first, Ctrl O, it will write this to the file, and then we press Ctrl X to exit. The next thing that we want to do is we want to run this exact same command, just this time we know that we have the correct password in that list. Let's press enter, and here it is. It managed to find the password in 1 second. You will notice as soon as it finds the password, it will stop the execution of the program, and it will print it right here. Key found, and in the brackets will be the correct password to that wireless access point. It scanned about 492 passwords out of 10 million, and in less than 1 second it found the correct password. How cool is this? And keep in mind that this is the speed of us running this from a virtual machine. For example, once I test this program on my laptop, it has a speed of 3,000 to 4,000 passwords per second. And in the next video, we're going to see how we can increase the cracking speed even more. So with Hashcat, which is the program that we will cover in the next video, we're actually cracking the passwords with GPU. And here, we're cracking the passwords with our processor. And cracking with GPU is much faster, therefore we should have a higher speed once performing the cracking with our Hashcat program. Nonetheless, more about that in the next video. See you there. Welcome back. So we have cracked the password with our AirCrack tool. We noticed that the speed was around 300 to 400 keys or passwords per second. We saw that it works once we added the correct password to our file, and we also saw some of the other options such as time left, the percentage, and the amount of passwords that have been tested. But right now, let's see how we can crack the password even faster using the Hashcat tool. So let me clear the screen from the previous video, and what I got on my desktop right now is I got the rockyou.txt password list, and I got the rockyou.txt with our correct password. Now, these are the two exact same lists from the previous video, just this one contains the correct password for our wireless access point. We're going to run the first one first, just to see the speed that we get and whether it is any faster than with our AirCrack tool, and then, just to prove that it works, we're going to run this list the next. So let's get straight into it. To run the Hashcat help menu, you can simply just type Hashcat. And to get even more options onto how you can use Hashcat, you can type Hashcat and then --help. And here is the help menu. Down here we got some basic examples of how we can use Hashcat, and if I scroll a little bit up here, we can see all of our available options. And you might be asking, what was the thing that I was scrolling through so much? Well, these are just different types of password hashes that you can crack. You have SHA-1, SHA-2, SHA-512, you got GetSuck, you got zip hash, you got MD5, different types of MD5 hashes, with salt, without salt. That goes for SHA-1 as well, and for any other password list that we can find. Now, you might be wondering, well, which one are we going to use? in our case, we want to find the WPA password hash. And it will be under these network protocols, and if I go right here, here it is. We want to use the WPA EPOL PBKDF2. And this has a code of 2500. Remember that, because that is the number that we're going to specify in our command. And up here we got something under the -A option, which is called the attack mode. And you simply just specify -A and then different attack mode. Down here at the lower part of the help menu, we get which attack modes we have. Let me just find where it is. I believe it's somewhere around here, and here it is. I believe these are the attack modes. So we got the low, which is specified with 0. Even though it says 1 right here, the low attack mode is specified with 0. And the 4, which is nightmare, is specified with -A3. Now we're going to be running the lowest attack mode, just so we can see how the tool works. So the first thing that we must do is we must type hashcat -A and then the attack mode. We're going to use the lowest one, which is 0, and then -M for the password hash. Remember, the code for the WPA password hash is going to be 2500. After that comes our cap file. But if you were to try to run this program with our .cap file, it would not work. Hashcat works with different cap files. We must convert this cap file to xccapx. How can we do that? Well, we don't have any tool that we can use in our Cal Linux, so we must go and do that online. What I'm going to do is I'm going to open up my Firefox, and I'm just going to search for cap to xccapx converter. Let's wait for this to open a new tab, and type cap to xccap and then x. Press enter. The proxies are refusing connections. This could be due to our burp suit being the proxy, so we're just going to remove it real quick instead of actually opening it. I'm just going to go to network settings and click right here, no proxy. Great, now I will refresh this page, and I'm going to go to this first link right here, which is pcap and cap file converter to xccapx. Let's click on that. Let's select our file. I will click on browse, and I will find my .cap file. Here it is. So I will select that one, and I will click on upload. This will upload the file for me, and as soon as it finishes, I should be able to download the xccapx file that we can use with our hashcat tool. So let's wait for this to finish. And here it is. I can click down here, download my file, and I want to save my file. It will be under here in the download section. As we can see, it has some weird name. Nonetheless, let's copy it to our desktop. For that, I'm going to open another terminal, navigate to downloads, and I'm going to copy our xccapx file to home, Mr. Hacker, and then desktop. Then I can exit this out, and the next thing that we specify right here is that file. So I believe it is called like this. You can rename it if you want to. I'm just going to leave it with this long name. And the last parameter to this function is going to be the word list that we're going to use. In our case, this is going to be rocku.txt first. This is the list without our password. So let's go through the options once again. The attack mode is going to be the lowest. The -M option specifies which password are we cracking. We're cracking WPA password, so we specify 2500. Then we specify our cap file that is converted for hashcat, and the last thing we specify is the password list. So I'm going to run this. It will tell me that this has been started. It will initialize this backend runtime for our device 1, and it will probably start brute forcing with my CPU. And the reason it does that is probably because we're running this over a virtual machine, so it can only detect the CPU. However, even with CPU cracking, we should still get faster cracking time than with air crack. All we need to do is we need to wait for this to finish, and as soon as that's done, we should start cracking the password. And here it is, it started cracking the password. It will not write anything right here, however, if we type S for status, we can check out what progress it currently has. So we can see some information right here. And anytime you press S, you will see the current progress of this cracking of the password. It will tell us which file are we using to crack, which hash name are we using. The progress and the speed is down here. It says 600 hashes per second, and this is equal to 600 passwords per second. So we can see it is almost double the amount that we had with aircraft. Down here we can see the progress as to what amount of passwords have we covered from 14 million passwords that we have inside of our program. And we can see we already passed 100,000 passwords. In the candidates, it tells you between which passwords it is currently at. Now you can wait for this to finish, however, even though it is currently at 1%, we're not going to be waiting for all of this to finish, it will take hours. We're just going to quit this with Q command, and then we're going to run the same command just with our correct file. So I'm going to use rawq with password.txt, and I'm going to run this once again. Just make sure that you added the correct password to the password list, and let's see whether it will manage to find it. And keep in mind that if you didn't run this on a virtual machine and you actually used the GPU to brute force the password, you could have up to tens of thousands of passwords per second. And the faster, the better. However, even with this small speed, we managed to find the password while I was talking. So we can see it printed it out right here. Here is the hash, here is the name of the actual wireless access point, and here is the password that it managed to find. So we can see it also did this in less than 1 second. While I talked, we got all of these results output. And this is a second option as to how you can crack the password of wireless access points. Now you can use the hashcat to crack some other passwords as well. We saw that there are a bunch of different hash values that you can use. However, we learned hashcat through wireless password cracking. Great. And that'd be about it for wireless cracking. So thank you for watching this video and this section, and I will see you in the next lecture. Okay, small pause. I just want to notify you that this is an update section and that here we're going to cover Android hacking. So in this small section we will cover the exploitation of the Android devices. Now, even though this is considered mobile hacking, compared to what we already covered by now in Metasploit framework and other tools used for payload creation, Android hacking won't be much different than that. As usual, we will craft the payload with our Kali Linux machine, and we will try to gain access to an Android device. However, you will see that this isn't quite easy or practical in real life as hacking a Windows machine, for example. Why, you might be asking? Well, you will see. There are many steps the target has to perform in order to execute our payload. However, if we make them do it somehow, we will have complete access to their Android device. Another thing is, some of you probably won't have an Android device laying around, so to make this accessible to anyone, we will be downloading and creating an Android virtual machine. That's right, we are simulating a mobile phone with this virtual machine. If you actually have an Android device, feel free to use that one instead to test these payloads out, as that would be the best practice since some of the post-exploitation options won't work on a virtual machine. Once we set up our virtual machine, as mentioned, we will deliver the payload to the target, but what is it that we're after on their device besides just having an access to it and being able to control it? Well, we want to, for example, extract all of the contacts from that mobile phone. We could also read the messages as well as send messages from that phone, and we can check if the device is rooted, and we could as usual download and upload files on that system. Those files can be images, applications, and other file types that we want. You can try opening a camera and recording, but most of this stuff we won't be able to do on a virtual machine. However, I will show you how to run those attacks nonetheless, just in case you try gaining access to a real Android device later on. Most of these things we will achieve using our Metasploit framework tool. we will create a payload for Android devices using MSF1, and we will catch